Okay, hi. Don't mind us and our technical difficulties. Who here hasn't had them in their entire life? All right. What? Oh, come on. All right, so yeah, this talk is Magical Beans and Mystery. It's kind of a navigation along the way as I've been trying to learn Spring and still continually am learning stuff and may have been still learning stuff a bit earlier. I see some people here who actually know a bunch of things already, and so hopefully I don't get made fun of too much. But yeah, so I'm Tiffany Jernigan. I guess I can go to the next slide here. But Tiffany Jernigan, developer advocate, was previously on the developer advocate team at VMware, so partially with the Spring team, but layoffs suck. So if you're hiring DevRel, please let me know. And my website's there with talks and stuff.
So my name is Timo Salm. I'm a pre-sales specialist for developer experience at Broadcom, focusing on the VMware Tensor portfolio. So actually part of this portfolio is Spring. So we have most of the paid Spring contributors. And yeah, now they are all part of Broadcom, as I am. My focus is on the commercial Spring products and also internal developer platforms on top of Kubernetes, so that all the developers can work really productive and spend most of the time with code and not with setting up their application for Kubernetes, etc. You may have heard that actually Spring is the most popular application development framework on the JVM. And more than 72% of the people, the Java developers, actually use Spring Boot. So one of the projects in the Spring framework ecosystem. So the question is actually why?
So let's start like a little bit of a history. So you may have heard, if you've been to one of the previous Spring I/O conferences or Spring One or etc. It was created in 2003. There's actually a cool web page on Spring One that you can actually walk through the entire history of things. Basically, it was created to address some of the complexity of the early J2EE specifications. So basically, just wanting to focus on things being able to be faster, being simpler, and just needing something that was more lightweight. It's not like a competition with Java or Jakarta EE. They actually are complementary to each other. And basically, there's things like speed, there's things like simplicity, there's things like productivity. It's enterprise and production ready. There's a huge ecosystem around it, which you probably know from even any of the talks that you've gone to through today. And by even just looking around this room, you can tell that there is a pretty active and large developer community here as well. So there are a bunch of official Spring projects. If you go to spring.io/projects, you'll see a lot of these, plus more. You can see the little text at the bottom. There's a bunch more there. So basically, Spring isn't just one thing. There's a lot of official and unofficial related projects that are out there. You can, again, find the official ones here. You can find some of the other ones as well. There's a lot of different projects that are focused on a bunch of different aspects. The core of everything is Spring Framework, which is the first one that you can see over there. And then there's things like Spring Boot, which, if you've heard any of Josh Long's talks, start.spring.io is his second favorite place. So basically, that is focused on things for developer productivity and integrates all these different things there. You hear a bunch about AI now. There's also Spring AI, so there's just a bunch of different things that are there.
Yeah, so let's start with Spring Framework. So how many of you already use Spring Boot to create an application? A lot, I'd say. Actually, how many of you use Spring Framework without Spring Boot to create an application? Only a few. And actually, it's like Spring Boot helps a lot with getting started. It abstracts away all the stuff you don't really have to know to build an application. But actually, it's really helpful to understand the core concepts or capabilities the Spring Framework provides. And what we'll do now is actually walk you through those different concepts. With that, you will really understand what's happening underneath in your Spring Boot application. And we will also show with that how much you actually have to do to get an application running with just this basic Spring Framework. And then we can also see what actually Spring Boot adds on top of that so that you don't have to care about that stuff anymore. So don't get confused in any way if there's something where you say, hey, that works out of the box in my application, that's because of Spring Boot. If it's a little bit more complicated to get to this state here.
So who here has heard of inversion of control or IOC? Okay, decent check there. Okay, so for the folks that haven't yet, basically it's a design principle that basically makes it so that creating or managing your object is not done from your application code. So if you were to think of this in a more abstract way, for instance, say you have a car and your car is not going to go and create and manage engines. One will be going and giving that to you. So we also have this concept of dependency injection. So dependency injection is the pattern that implements inversion of control. So there's a few different types. There's constructor injection, which is what you can see in the code that is over there. So if you were not using dependency injection, for instance, you would not be passing in this repository and you would be creating a new repository. But instead, we don't want to go and create it. We want this to be handled by what we'll have as our IOC container. So one of the key benefits of this is that it can basically help with testing. You can end up doing things with having mocking. There's a bunch of different things that are built in, especially as you get further into things with Spring Boot. You can have different implementations based on different environments that you may end up having. So basically, it's just making it so that something else is controlling and managing all these different things that you can end up passing in and being able to change those around, etc., instead of having each thing with your code having to go and create that. So that makes it easier to maintain, is more flexible, you can have different types of testing, and there's just a bunch of things out there.
Okay, perfect. So now let's have a look how actually Spring provides this inversion of control. And as Tiffany already mentioned, so actually there are several ways to do that, and usually that's then provided by a framework, or in this case a container. So there's the Spring inversion of control container. That's a really core part of the Spring framework. And actually it manages your plain old Java objects, so just your objects that are not managed in any way. And those managed objects that then, for example, will be provided into your classes that have dependencies, they are called Spring Beans. Those are just the managed objects with their metadata, and the Spring ISC container will care about creating instances of them as you require and set everything up for you. To access actually this IOC container as an interface, there is a Bean Factory interface which you can use. And there's also a sub-interface called application context. So this is a really often used term for everything about the Spring IOC container. And this application context actually adds some additional functionalities like or methods for resolving messages, internationalization, etc. So how can we configure our metadata for the Spring IOC container? And actually there are several ways. So in the past, the most used way was to use XML. So there's an XML where I define all the different Spring Beans, so the managed objects I'd like to have. And then I create a context out of it, and the IOC container takes care about everything related to dependency injection, etc. Nowadays, more and more people use Java configuration, and actually it's not like that there's a recommendation which one is better, because all of them have, so Java and XML, they have the benefits. One of the benefits of XML is actually that there is a clear separation of configuration versus code, so you don't mix configuration with code, which is usually best practice. But nowadays, I'd say most of the people are using Java because they are familiar with it, and it's a really nice way to actually configure your container. There are also annotations available. You may have heard some of them about some of them called @outwired. We will see this later, to actually inject dependencies and mark, for example, different fields where you want to have an injected dependency instead of providing an instance. And there are also so-called stereotype annotations. So for those that actually use Spring Boot, they have seen them and used them without maybe knowing what happened underneath, because it's like in Spring Boot, if you declare your service with add service, or your resource with add resource, or your REST controller with add REST controller, those are those stereotype annotations. Those will be detected by a so-called component scan automatically and created as a bean instance. Actually, in addition to typical metadata for beans like name, constructor arguments, or properties, there's also a scope. Actually, it's like if you, as I said, don't want to achieve something specific, it's like every of your beans will be a singleton, which means that in your application, entire application, there's one instance of the bean. Actually, it could be the case that you want to inject just different instances in your different classes, and for that you can change the profile, the scope to prototype. Then with every injection you have, there will be a new instance created, and especially really useful for web-aware applications. So if you have a REST API, for example, that you provide with your application, there are more scopes available, like for example a request scope or a session scope, so that you have one bean instance per request or per session. So like for example, per request, you could have user data in that bean, which is only for this one request. So if you have multiple requests from different users, then you can access only the user info of that request, which is really helpful. So yeah, enough slides. Let's have a look at the code. And actually, it's like you can see, we have several projects here. All the code is available on GitHub. You can have a closer look, try it out. And if I want to create a Spring Framework application, actually it's not that easy. It's not like with Spring Boot where you go to start at spring.io. It's like you start with a plain Gradle or Maven object project. So in IntelliJ, for example, you can just do file, new project, give it a name, then you select Java or Kotlin if you'd like to. Whether you want to have Maven or Gradle as a build system. The JDK version, in this case, we are using 21 because it's the latest long-term release of Java. And then because it's, in this case, JDK 21, we need a compatible Gradle version. 8.1 is not compatible with 21. The minimum version you need is 8.4, so you can change it here to 8.5, for example, and that's it. So then we have a plain Gradle project and can run it with the Gradle CLI. Actually, to get the minimum capabilities of Spring, what we need in addition, so that's then what you have if it's generated, we at least need the Spring context actually dependency, which provides us all the core functionality of the Spring framework. And yeah, with that we are ready to actually have a look at the application context, define our beans, etc. The first thing I want to show you is really how to define it via XML that you have that you actually saw at one time. So here in the resources I have the beans XML where you can see I defined one bean here. The recipe service with a constructor argument, so in this case it's a list of burgers, so the sample application that we want to show you is a really, really basic version of a recipe list where I can add recipes, I can fetch recipes, yeah, so that's really like the service that provides some of the functionality here. If we go to the class, it looks like that, so it's just a class. It has this constructor argument with the recipes, list of recipes, and for the first version we only have a fetch recipes method, so really basic, and that just defines the bean metadata here for it. And if we then go, in this case, to our main method, we can see how to create this application context. So there's a class called class pass XML application context. So we want to create an application context out of this bean XML. And yeah, after that, actually, everything will be done for you, and we can access our bean via the interface of the application context. You can see then we have the instance, and for example, call the method. So that yeah, works really great. So we are back. Yeah, what I showed you before is how to set up this XML application context, so based on XML configuration. And now let's have a look how you do that with Java. For that, we have a class called annotation config application context. And here I have my configuration, so this app config class, which actually defines more or less the same as I did before. So I have my add bean annotation to actually provide those instances that should be managed by the container. You can see in this case, for example, a list of recipes that will be managed by the container, and then I can inject it into my code. Like, for example, here in the recipe service, where that will be automatically injected by the IOC container. What you also can see is that I don't define a recipe service here as a bean, because actually, even if I'm using it here, you can see I try to get it from the context. This is actually configured or detected by so-called stereotype annotations. And the one we are using here is at service. This is what I talked about, okay, that maybe in Spring Boot you just annotated or your classes with those stereotype annotations and didn't have to care about the injection. And actually, based on that and the add component scan here, those will be automatically detected, those beans you would like to have by the Spring framework or the IOC container, and provided to you so that you can use them. Also a note regarding Spring Boot, that's something you also don't have to do because all of that is part of this so-called auto-configuration, which we'll learn later. Great. If we run it, let's try it again. Maybe it will work or not crash my computer. We are able to see that actually it worked. So we have the class path, application context, and we get a list with a burger. And for the annotation config application context where I created those bean and injected it, it also worked. We have some more recipes, which is great. So yeah, that worked quite well. Let's see what's next. And the next really core functionality Spring provides is an environment abstraction. As you may know, it's really important or best practice to separate configuration from your code to be able to run your application in different environments without code changes, so that you can configure everything with, for example, environment variables or configuration properties and don't have to change your code for it. As it's also, for example, best practice to deploy the same artifact of your application, so same jar file, same container across all your environments, and for that you actually need something where you can provide different configurations for them. And this is what is provided by the environment abstraction, and there are two key aspects. The first is profiles, and the second is properties. Profiles, they really help you to actually define beans for different environments. So, and you can do that with the add profile annotation. And in the example you can see on the right, it's for example like, okay, I have one data source, an in-memory database I want to use for development. This is why I have the profile development. And for production, I for sure would like to have an external, for example, PostgreSQL database. And for that, you have two different beans, and based on the profile you set, those will be actually provided by the Spring IOC container to you. So you don't have to care about changing or having multiple implementation, adding checks for it, etc. That's all done by you with the IOC container and the environment abstraction. So let's have a look at it. If we go back to our example in the app config configuration, we can already see that we actually defined a different recipe list here, which is actually for production in this case. So we had the add profile production. We also, because of the fact it's like by default, there is already a profile activated, which is the default profile. Without specifying a profile here, this bean will exist. If we then activate the profile production, we have two beans of the same type that actually exist. So we need a way that the Spring IOC container knows which one it prefers or we prefer to inject. And that's what we do with the add primary annotation. With that, we can say the Spring container, if someone is asking for a specific type of bean, then the one with add primary is the one I should provide to the class. What you can also see is like, okay, or let's first try it out. We can already see here in the code, so the main code here, if I run get active profiles, I already activated the production profile. You can do this either via configuration properties, which is done here. You can do it via an environment variable. So in Spring, if you have a configuration property like Spring profiles.active, you can provide the same configuration via environment variable. You just have to replace the dots with an underscore. So Spring underscore profiles underscore active. If you provide this environment variable, for example, in your shell or Docker container, whatever, then this actually profile will be active. And in the example, we can see the current profile is production, and the recipe list is the one for production. So in addition to burger, we have some more recipes. And there's also like, you can have multiple profiles. So it's not like that you only can have production or development. You can also have others. It's really a list of profiles that are active. The next key aspect is the properties. And actually it's like the property source is a simple abstraction on key value pairs. And it's like, you may know them from the configuration files that you are already using, but also for the environment, so getting keys and values from the environment is another property source. And for actually the Spring framework, so the framework out of the box provides one for JVM system properties and one for environment variables. So this is how actually you can define by default with the Spring framework configuration properties, and those will be detected. And it's like there's different types, they have a hierarchy. So if it's like the environment property source usually overrides configuration properties you have in your properties or YAML files. So it's really about to know about the hierarchy, to know where to set it and where you can override it. Actually, it's like we can see on the right. So also as an example, with a property source annotation, we can define additional property sources, like here with the application properties. I think a lot of you already use application properties, but actually it's like that's something provided by Spring Boot out of the box, and it's not in the Spring framework. So that's something we added here manual. This is why we had to add it. So the add property source ClassPath application properties. Another thing you can see in our config, so here is the property source, is that actually we use the add value annotation to inject properties. So you can access them via this environment abstraction from the application context. So inject the application context and then get environment and get property. But actually it's also like easier to inject it via add value. And here it looks a little bit complicated. Actually it's like add value is not only to inject properties. And there you can actually use something called Spring Expression Language. It's really provides a lot of capabilities. You can see it in a way here. So we first actually inject the property, which we have defined in our application properties. And we also, in addition, run a method in this as part of the Spring expression language. So it's a string separated with commas. We split it with the split function created in a string array, and then the add value annotation is able to convert that in the type we provide here, so list recipe. And with that we have a list of recipes coming from a string in our properties file. So that's it about environment variables, and you may have recognized that in the properties property source there is a class path colon, so a prefix. And actually this prefix is for a resource loader, and that's something also Spring provides actually. So it's like a resource is an interface to access low-level resources like files, things on the class path or URLs, and there are several built and available, like also for URLs. And actually there's also a resource loader interface which, for example, the application context implements to be able for you to access those resources. You can see it here with the context get resource as an example, so getting the application properties from the class path. And that's also something part of this demo here. If we scroll a bit down, we can see I use the application context to access the resource without a prefix, and by default that's always the class path. And I do the same with a file colon prefix, and then the file resource loader will be used. And if I scroll down, you can also see that here that it's a class path context resource, and then it's a file URL. One more core concept that we would like to talk about is aspect-oriented programming. Actually, that's a really great programming paradigm. And actually enables really the modularization of cross-cutting concerns. So really code that you have across different classes to achieve a specific capability. One of the examples is transaction management, where you have usually to wrap all your database calls together, etc. And that's something Spring Framework really provides support for, which is it's also heavily used in the framework, so we will not have a closer look here yet. It's just good to mention it, but we will see usage of that in the Spring Framework later. And there are several terminologies, like, for example, a join point is a point of execution in the program. A point cut is a predicate that selects specific joins of join points. So like if I want to run code before I do a call to a database and afterwards, and then the advised actually the implementation for those point cuts. So where you can say, hey, before call to the database, run this type of code, and after also. And with that you can really implement cross-cutting concerns. So that's about the core functionality that it provides, but it provides a lot more. So it's really, I'd say, the core functionality for everything you know about Spring Boot, etc., all those integration. The importance parts are already integrated into the framework, and then other frameworks, they provide additional capabilities. And the first is for sure, every application needs testing, and with the Spring Test module, Spring Framework really provides the core functionality to test your stuff. Actually, it's like, because we're using inversion of control and dependency injection, that really helps us, as Tiffany already said, with testing your code, because you can provide all the dependencies just by creating mock objects, etc. And with that you can really create unit tests with, for example, JUnit, and you don't have to care anything about the Spring related things. If you want to do still, for example, your implementation is based on the stuff in the IOC container or the environment, you're, for example, accessing some beans, etc. There are classes for it, like the mock environment or the mock property source. And there are also several helper classes, but actually it's also like that there is, for integration testing, in this case, it's really like I want to test my application with a setup context. There is also a Spring test context framework. Let's have a look at a minimal test, how it looks like. So first, for sure, I have to add my dependency, and also with a Spring framework, it's like those dependencies, they don't include everything you need, for example, to, in this case, JUnit. It's like you have to add the implementation, for example, for the testing framework you want to use. You have the dependencies manually, and as you can see, also define the correct version of it, which is different compared to Spring Boot. And then if we have a look at the test, we can see that with the context configuration annotation, I define my configuration class, so the app config. This extends with the annotation, with the Spring extension, actually extends or integrates the Spring test context framework into JUnit. And then you can see, because the context will be fully created for me, I can also inject, that's the auto-wired I talked about, so that annotation to manually inject the stuff, which is not needed that much anymore, because all the constructor injection, etc., is done automatically for you. And then we can use test our functionality as we know, based on, for example, JUnit with assert annotations, etc. There are some additional ones, like you said in the code, I use different profiles. For that I have active profiles, and the active profiles annotation I can only use on classes. And therefore, I have a nested class here where I define my production profile, also the test property source to define or override the configuration I get from the application properties. And with that, then I also can run my test on this different profile. Web applications.
And also for that, like if you wanted to use like test containers and just like for spinning up like a database of some sort and you have a bunch of questions, there's actually a test containers booth over here today. Yeah, so a lot of the times when you are starting off with Spring, you probably end up wanting to just create maybe even like a web page that says hello world or something like that. So there is the Spring Web MVC module. So MVC is Model View Controller, and so that's built upon the Servlet API. There is also the option of going with reactive streams. So there's also the Spring Web Flux. So depending on what you want to do, you can look into those. So in the Spring Web MVC, there's this thing called the dispatcher servlet, and basically it ends up giving you a shared algorithm for request processing, and like the actual work is performed by like components that things are delegated to. And seeing with how Spring is, there's that whole concept of annotations. To actually go and enable that, you need to have the @enableWeb MVC annotation, and that has to be added to some sort of @configuration class.
And actually, it's like to run those app applications we saw before. We run our application just from a main method, so Java class, and then via Gradle or just Java, we were able to run our application. Actually, it's like for web applications, we need an application server. And therefore, we actually first have to configure this dispatcher servlet and the application context. And we also need an instance of Tomcat, for example, to run our application. So the configuration of this app initializer, so it's called, we could also do it via web XML, but in this case we're doing it via code. So with an app initializer, it has to implement the following interface here and override the startup method here to provide an application context. You can see now it's an annotation config web application context. And we also configure dispatcher servlet, so really the handling of all the requests that are coming to Tomcat, and then based on our request mapping, etc., delegating that to the different delegate components to actually do the business logic. And that's something that will be auto-detected by application servers like Tomcat, etc., if we provide our application as a WAR file. For that, we actually added the WAR file plugin here, because otherwise our application will be created as jar, and it's not easy possible to run a jar on top of Tomcat. Okay.
Yeah, so then you also need to have annotations such as like controller or REST controller if you're doing something with like REST calls. So you can have this thing that is also called like get mapping. For instance, you could have something at like localhost or whatever your page is /API/v1/recipes, and being able to just like do what you might do with curl or something like that and do a get on that. And I think we're going to have to skip through things a little bit faster since I believe we only have 10 minutes left due to technical difficulties and such. So then there's also data access. So who here has used a database at some point in time? All right, cool. So basically, Spring helps make that be easier. So it provides abstraction for transaction management. So there's things that use, like, there's JDBC, there's Hibernate, there's JPA, which you may hear about a little bit more if people are talking about Spring Boot. And so, like, basically these transactions can be declared either programmatically, or the recommended way is actually doing it to do it declaratively. So that you can use the @transactional. So if you look over at the code on the right over there, right above the @recipes. And then there is also an enable transaction management annotation. So basically that enables it for the declarative approach. And so, like, basically, like, you have your @service and then your transaction there and what logic is happening in there. And so, like, a key part of like Spring's transaction abstraction is like this thing called a transaction strategy, and that is defined by this thing called a transaction manager. I don't think we have time to go on that.
So one thing here is that actually this transactional, it's also something relevant for Spring Boot, but actually it's like you only have to define it, and this is why you can see it on a service, not like on a repository, if its transactions are business code. So it's like, I want to add multiple recipes like here, but if one of the inserts fails, I want to roll everything back. That's, for example, what you define in a transaction. And this is what you use this as at transactional for. So if it's like I only have one insert, then you don't have to define this at transactional. It's only about if you have different things that modify something and you want to roll them back automatically via Spring.
Okay, so then there's also, as mentioned like a couple seconds ago, there's JDBC. This is one of the most commonly used ones. It stands for Java Database Connectivity. So basically this is where Spring takes care of like a lot of the low-level details for you, like the transaction handling. Like it is basically like the lowest level way of being able to like, with JDBC template is the lowest way of being able to approach it using JDBC with Spring. So I'm gonna actually let you explain this part.
Okay. So actually it's like, so that's really the classic way of doing it with the JDBC template, but actually it's like since Spring Framework 6.1, there's also a JDBC client, which is a little bit of high abstraction on top of it, which, that you can use to actually run your SQL scripts, as you can see here. And actually also Spring JDBC provides an embedded database support, like for example for HSQL, which you can use for development and for running tests, so that you don't have to run your your database on your local computer or in a computer in a container, etc. Just that you see it once here. Even we have not too much time. So this is then how such a repository looks like. You can see we are using the stereotype annotation to actually automatically recognize it by the Spring IOC controller. We inject our JDBC client, and then, for example, to fetching the recipes, we are using it via JDBC client.sql, select star from recipe, and then we also have a great role mapper that we can easily convert the result to our domain class. Same for inserting, there are methods available, and actually you can also see here in the service the transactional for adding multiple recipes. Okay. And actually it's like Spring Framework provides a lot more core functionality for a lot of different integrations, like for example observability, caching, if you have external calls to, for example, databases, and you can use them in memory caching or something like Redis, so it's a really nice way to do that. And also for newer technologies like JVM, checkpoint restore, which we also have talks about regarding improving the startup time of your Spring applications. That's about Spring Framework, so let's have a short look about Spring Boot.
Okay, wrong direction.
Yeah, it's like...
Okay, so yeah, since a bunch of people in the room already raised your hands, I assume that most people have started off at the Spring Initializer or start.spring.io, where you can choose things like whether you're using Gradle, if you're using Maven, Java, Kotlin, etc. But basically it just makes it a lot easier to start off your application. You can choose what dependencies that you end up wanting. So like we were talking about things with web, we were talking about things with databases, so there are dependencies that you can specifically add there. So basically there's this way of dependency management that Spring Boot has. So depending on whether you're using like Gradle or if you're using Maven, it looks a little bit different. But basically there are specific dependencies that are curated based on like what versions can work with each other. So that way you don't have to go and figure that out and make sure that everything works. It already will. For the one specifically on Maven here, you can see that it specifically mentions Spring Boot starter parent. So there is a concept of starters. Basically, they are like a supported set of dependencies. There's ones for a bunch of different things. You can see there's Spring Boot starter for web, there's Spring Boot starter for test, but basically it has a bunch of the dependencies that you need for that specific thing with all the versions that work together.
We will just show the code at the end.
Okay. So there is this annotation for at Spring Boot application. So basically that automatically configures your application based on your added dependencies. So say if you have something with like a data source, so you have maybe like a database or something like that, and you have it set up in a certain way, and then it knows, hey, I need an in-memory database, I'll go and set that up. There is component scanning, so basically it will go and check to see like either things that are specifically annotated with things that Spring already has, or if you do @bean on different on things that you specifically go and create. I'm just getting nervous because there's like 4 minutes left.
Yeah, actually, the important part is here what Spring Boot provides on top of the Spring framework is dependency management for you. So we'll show that in a second. It's really easy to get started. I want to have data JDBC. I just add this dependency. I have everything. I have plus. So all the versions, all the dependencies that the Spring team thinks you know. Like for example, also with the testing JUnit, etc. for the testing starter. And then actually it's like all about auto-configuration. So you saw some of the examples with a lot of annotations, etc. All of that actually cares Spring Boot for you, and it really makes sense afterwards. If you have some time, have a look at the Timo code, so what all is configured there, and then as a comparison, what's part of Spring Boot.
Yeah, so for instance, like all the setup that needed to be done with with Web Servlet and Tomcat and all those things, you don't have to go and do that with Spring Boot, or the part that we weren't able to show for setting up things with a database. Those things end up getting set up for you. You can also have, there's this application.properties or application.yaml where you can define things like what is my data source URL, like what is like the port that I need for my database, what is my username, what is my password, and different things like that. And it automatically goes and will load that into your class path. So things that you couldn't easily just go and do when you're doing things with Spring Framework.
And actually it's like you saw that before in the demo, I did that manually, added a property source, and that's something Spring Boot does automatically for you based on this naming convention like application.yaml or properties, and also if you have different profiles, application minus, for example, production.yaml. So a lot of additional property sources actually configured for you, and you don't have to care about configuring them in your application.
And then you can have like different application, like / some sort of profile, whether it's like dev or production or whatever it might be, and then you can actually go and use the add value annotation to get a value specifically from there. Then also, like basically by default, like if you're just like doing dev, your application is packaged in some sort of executable jar. You can use java-jar for an Uber jar. You can use Maven with Spring Boot Run. You can use Gradle with Boot Run.
And the important part here is that we saw that with the actually Spring Framework, we had to provide a Tomcat application server to actually run our application. And without it, we are not able to run it from the command line. What's different with Spring Boot provides an embedded Tomcat to run your application with ease. So via plugins, for example, for Maven and Gradle. And also like if you have this executable jar, the Tomcat is part of this jar, and with that you can just run it with Java jar. So you only need in your container the JRE, and because of the fact that the Tomcat is part of the jar, so you don't need an application server. You can provide it, then you have to unpack it, but actually it's like this Tomcat is already part of it, because it's really boosts the productivity of you and not having to install Tomcat, for example, on your local computer.
And then if you're doing things with production, like you could basically still use an executable jar. There's things that can help with, like if you unpack it, it ends up helping with startup time. You could also do other things like using Graal VM, and there's a bunch of different things out there. You can also go and just use Maven or Gradle to actually build your Spring Boot container image from your code as well. So then you don't have to go and use Docker files and then throw it in your jar and whatnot.
And especially with all the best practices Spring provides for those called build packs. So it's like they're detecting your application based on that. They are providing best practices also for the base images, etc. And we don't have to care about it.
And then testing, because again, testing is super important. There is a Spring Boot starter test module. So basically with this, it provides a mock web environment it just makes it a lot easier to be able to do mocking, to be able to do your testing than having it with just a Spring framework. You can have like specific test annotations, and then that can be customized as well. I'm just trying
so actually it's like what Spring Boot provides usually is either additional functionality on top of it, but mostly as that all the auto configuration, etc., are provided to you with the dependency management. So some new annotations or functionalities, but it's like really a lot of the core which you will see on the demo at the end. Yeah. And there's also the support of Spring Boot for test containers, which was not released recently, as Tiffany said. The booth is here of the test containers team. Feel free to reach out to them. And one more really important aspect actually is monitoring, metrics, etc. And that's something provided by the Spring Boot Actuator project. So this is where you have health endpoints. All this basic functionality for observability is there via a facade called Micrometer, so that you are not dependent on a specific observability solution. And that you just have to add this dependency. For sure you can do some configuration, but everything is there for you. And then you have the actuator endpoint where you, as that, can, for example, get the health, also create liveness, readiness probes for Kubernetes, etc. All the functionality is there for you. You just have to use it actually to get production ready. For web applications, as Tiffany already mentioned, it's like it makes configuration a lot easier. You don't need a lot of the annotations to enable the stuff. A lot more converters, formatters, etc. So that for common cases, everything is there. You can just use it. And also, just to mention that the Spring Web MVC framework is not only for REST controllers. It's also like with the Together Thymeleaf or another templating engine, you can also create a real web front ends without changing the business log of your code, just adding an additional controller that actually provides the information for this view. And for Spring Boot Starter JDBC, it's a little bit different because there's one additional really great interface, which I will show in a second, because it's like making stuff so much easier. So I think you remember all the JDBC client, SQL stuff, but there is actually CRUD repository, a list CRUD repository interface, which we just have to extend, and we don't have to write for common CRUD functionality, so getting a list of recipes, adding a recipe, any line of code, or any SQL script, all that will be generated for you, and if we then consume it in a service, it's just like before. So really great way for common REST configuration. Yeah, you don't have to care about it, and actually it's really hard to write good performant SQL commands, and that's something handled for you. Do you want to take it or?
Yeah, so security, super important. There is the Spring Boot Starter for security. Basically, if you're doing things like with authentication, with like whether it's basic OAuth or OAuth, you can add another dependency for that. So for instance, with our application, which we aren't able to really show, basically it will force you to have a login instead of being able to just directly go and see whatever application that you have there.
And actually it's like, so the Spring Security is just a project than any other. It's not like only available with Spring Boot. It's just like Spring Boot makes it really easy to integrate it, and it's like with all the auto configuration, because there's a lot to configure. It's really an ease of use. So for example, in our web sample that you can see, there's just like, it's commented out, and if you remove the comments, it's like without anything, any configuration, just adding this dependency, you have basic auth in your REST API. So really nice way to add security without any huge configuration.
Yeah, this is kind of what I was mentioning before with like the starters. So like we have one for web, we have actuator for like having health endpoints, we have one for JDBC. If we were to take a look into our resources, we have like an application.properties. The only reason that this data source URL is needed for the embedded one is because we're using Postgres. You can also go and create one for, say, dash production, and then have your Postgres set up there. Obviously, you shouldn't directly put your password in there. That's not so great. Then you would have things like having your schema, like creating a table if it doesn't exist, and then like you can actually go and put values directly into that. For our recipe, we're just using a record since we're not trying to go and modify what's in there. The repository is what we just talked about. If this is just the initial thing that you get directly from the initializer, they basically all end up looking like that. We have, our service, which we looked at, which is just going and like finding what is in there and saving them. And then this part here is what we're doing specifically for like the mapping, so request mapping, so that we don't have to do /API v1 recipes every time. But basically, you just have like a get mapping, and then that can go and fetch all the recipes. You have a post mapping, and then you can go add something to it. But basically, it'll be a lot easier if you actually see the code. But if we go to, I'll jump back here. But here is the QR code that has all of the code for everything. That'll make it a lot easier to be able to see just like how much code there is if you're trying to do all these things via just having Spring Framework, and how much is abstracted away and things that are configured for you if you're using Spring Boot.